All right, so we are going to look at solving exponential equations. Um, what helps on these is if you put kind of some context to it rather than just memorizing the process. So what I've done here is giving you this example. So let's say we have an experiment and we have 7,500 cells in a petri dish, and after 4 hours they've multiplied to 23,000. Okay, so doing that allows us to remember a little bit easier where to put these numbers. Okay, so our ending value is going to go in for y, so that's what we ended up with, 23,000 cells. Our initial value is how many cells we started with. What we're trying to figure out is b, which is the growth or decay rate, how fast it's growing or shrinking, and then x is the time. Now, in the book, they're just going to give you these two coordinates over here and assume that you can figure out where to put them. It's a little bit easier if you put it into, like I said, like a context with a story. So at time 0, there were this many cells. 4 hours later, we ended up with that many. Okay, so know that they're not going to give you a word problem. They're just going to give you 2 points, and they want you to solve for what the equation would be. So here's how we do this. We need to first find b, so we're going to solve for b. So we're going to put our ending value here, our starting value here, and then b raised to the 4th power. Okay, how would we solve for b? Divide by that coefficient in the front. Someone tell me what that is? What do we get? How much? The 7 is repeating? Or 0, 7? Oh. Okay. How are we going to get b by itself now? We're going to 4th root. Easier way to enter it into your calculator would be to raise it to a power. So what power would we raise both sides to? Not negative. 1/4. Remember, we're trying to get this exponent to be 1 so that the b is by itself. So if you raise this number that you get, just hit the caret button, raised to the 1/4 power. What do we get for b? What do we get? 1.88, you said? 3.8? Somebody else get that as well? Just as a double check? Are we good? Yes? Okay, perfect. All right, so we solved for b. That's our first step. And now we can write the equation. So equations always have x and y in them, so those are going to stay x and y. So we have y equals, we're going to put in our a value, which was 7,500, and then we've got 1.38 raised to the x. So if the problem just says write the equation that would model this, this is where you would stop. This is your equation. Now, they may ask you to take it one step further and answer a question based on that equation. How many cells will be there in 14 hours? What do we do? Yep, 14 goes in for x. So in your calculator, all you're going to do is punch in 7,500 parenthesis 1.38 raised to the 14th power. How many cells are there after they've multiplied that many times? It's a big number. Somebody read it off to me. Did I hear you right? That? Okay. So that's how many cells would be there after 14 hours. Questions? Process will be the same every time. So think of your two coordinates in terms of cells. Okay, at time 0 we have this much and this many days or hours or whatever amount of time unit you want to have here. We end up with that many. All right, the other type of problem that we're going to look at is looking at compound interest. So if you put money in the bank and they calculate interest on your money every so often, we use this formula right here. Okay, so we're going to talk about what each of these variables are looking at. So P stands for the principal, which means the amount of money you start with. A is just how much money you end up with after letting it sit there and accrue money. R is the rate, the percentage rate. N is the number of times it's compounded. And I'll explain that in a second. And T is how long it sits there. Okay, so we're going to try this problem right here. So we're going to put 2,500 in the bank at 4.6% interest compounded weekly. How much will I have in 8 years? Okay, so we are figuring out what A is, the ending amount. We're going to start with 2,500. 1 plus. Now when we put the rate in, we can't write it as a percentage. We have to change it to its decimal. So how do you do that? To figure out what this rate would be in, not in a percent, but as a decimal. This might be easier. If I had 55%, what is that as a decimal? 0.55. What did you do? Yeah, you take this decimal point, which we don't write, which is right here, and we go boom, boom. Okay, so right now our decimal point is right here. If we move it back twice, we've got 0.046 for our rate. You have to do that, otherwise you're going to get it wrong. Okay, now the number of times it's compounded, this is how many times you would compound it per year. So if we're compounding weekly, how many times is that? 52. We should all know that. If it's monthly, what's our number? If it's daily, what's our number? 365. Okay? And we're not counting leap years like it is this year. All right, and down here, this is just a clue. If they say semi-annual or biannual, that just means twice a year. And bi-monthly or semi-monthly means twice a month. So what would the number be on this one down here on the left?
2.
This would be a 2. What would this number be?
24.
24. If it was bi-weekly, what would it be?
104.
104. Good. All right. We need to raise this to the NT. So N is this number, 52 times 8, because it's going to sit there for 8 years. Now, the hardest part about this is not writing this down, it's putting it in your calculator. So I need all of you to get your calculators out, because I need all of us to get the same answer. I'm going to write down the long line of how you should type it in. Okay, the parentheses are the key here. You'll notice we've got our initial number 2500 and then parenthesis 1 plus. This fraction right here you have to put in parentheses. You can't use the fraction button right here. You have to use the division symbol because your calculator does not like decimals in a fraction. So you have to do 0.046 divided by 52, parenthesis, parenthesis. And then when you raise it, this whole thing right here is in the exponent, so you have to put parentheses around it, otherwise you won't get the right answer. So I want all of you to type this in and hopefully all get the same dollar amount in the bank. So if you want to write down this right here so that when you're doing your homework, you know how to punch it in, that might be a good idea if you wouldn't have known this beforehand. What's our grand total number? Anyone got it? Yep. So 52 cents? Somebody get a different number? Okay, what did you get? 3,768. What are other people getting? You got this one? We're going with majority rules?
Oh, what did I do? Oh my god.
So we're good? Those are the only two types of questions on your homework today. Any questions?
Wait, so we only have two questions?
Two styles of questions.